Okay, so n is my number of rectangles, right? And I want to know what the length of each subinterval is. So what is delta x? So that's equal to b minus a over n. And I need to consider my interval. The length of the whole interval is going to be 12, right? Because my interval is from 20 to 32. So that this is 32 minus 20, and then divided by n, the number of rectangles, which is 3. And so this gives us 12 over 3, which is 4. Okay, so now drawing this in, I'm going from 20 to 24, and then 24 to 28, and then 28 to 32. So here's my 3 subintervals of length 4. And then this would be my left, this would be my right, left, right, left, right. And so now I need to figure out what is the midpoint. So what's the middle in between 20 and 24? Well, that's going to be 22. And then going to the next interval, what's the middle between 24 and 28? 26. What's the middle between 28 and 32? 30. Okay. And so I'm going to get that the midpoint Riemann sum is equal to delta x, which is 4, times f of 22 plus the length of my second subinterval, 4, my delta x, times f of 26 plus 4 times f of 30. And now just plug in the values, so I get 4 times f of 22, which is 29, plus 4 times 11, plus 4 times 5. And then now actually doing this computation out, I get that this is 29 times 4, which is 116, plus 44, plus 20. And so I'm getting that this is 180. Okay, so let's now look at another example. So before we get started with this, I just noted to you that if the function is concave up, the trapezoidal sum will be an overestimate. And if the function is concave down, the trapezoidal sum will be an underestimate. Okay, so increasing and decreasing has a connection with left and right Riemann sums, whereas concavity has a connection with trapezoidal sums. So now it says, suppose f is concave down on the interval from 2 to 10. Using n equals 4, find the trapezoidal sum. Okay. So I know that my n is my number of rectangles. So I have that my delta x is b minus a over n. And my interval is from 2 to 10. Oops. So I have that this is going to be 10 minus 2 over 4, which is 8 over 4, which is 2. So now drawing these, my subintervals, I have from 2 to 4, 4 to 6, 6 to 8, 8 to 10. So I have my 4 subintervals of length 2. And now I want to compute the trapezoidal sum. Okay, so what I'm going to do is I'm going to look at each subinterval, left to right, left to right, left to right, left to right. Okay, and what happens is I plug in each endpoint within each subinterval into the function, and I average them together, because I add them together and divide by 2. So what I'm going to do is I'm going to say that this is f of 2 plus f of 4 divided by 2. And then times my height delta x, so times 2. Plus, and now I'm going to do the same idea now with the second subinterval. So now I'm using 4 and 6, so I'm plugging in both 4 and 6 into the function, dividing by 2, and then times by 2. Plus f of 6 plus f of 8 over 2 times 2 plus f of 8 plus f of 10 over 2 times 2. Okay, so this is really long. So now I just need to plug in the function values. So f of 2 and f of 4 give me 1 plus 5 over 2 times 2 plus 5 plus 8 over 2 times 2 plus 8 plus 10 divided by 2 times 2 plus 10 plus 11 divided by 2 times 2. Okay. And so again, you can double check and just make sure that you accounted for all the trapezoids, because n equals 4 is the number of trapezoids. All right, usually we were thinking of the number n representing the number of rectangles. It works the same way with trapezoids. N equals 4 is the number of trapezoids. Okay, so we do have 4 trapezoids that we're accounting for, right? If I highlight all of these, so that's the area of the first trapezoid plus the area of the second trapezoid plus the area of the third trapezoid plus the area of the fourth trapezoid. Okay, so we're doing everything correctly. And now, just applying some algebra. So what you can do is you can actually cancel these 2's to make things a little bit easier. So now this becomes 6 plus 13 plus 18 plus 21. Okay, because I just added 1 and 5 give me 6, 5 and 8 give me 13, so on and so forth. And so adding these together, I get 19 plus 18, which gives me 37, plus 21, which gives me 58. And so that's how we would compute midpoint and trapezoidal sums in a table.